A smooth block is released at rest on a 45-degree incline and then slides a distance d. What is happening? This is a smooth block and this is the incline, right? This is making an angle of 45 degree with the horizontal, and this is the block. So this has to slide down through a distance d. It has to slide a distance d. The time taken to slide is n times as much to slide on a rough incline than on a smooth incline. So basically there are two inclines, both making an angle of 45 degree with the horizontal, and one is rough and the other is smooth. The distance in both the cases is d. Let us assume this is smooth and this is rough, right? So what is the acceleration in this direction? Initially they were at rest, so it will be g sine theta over here, right? And since this is rough, so that means acceleration will be g sine theta minus f by m, right? Acceleration will be equal to g sine theta minus f by m. And what is the friction force? Which is mu into n, right? If this is normal reaction n, so in this direction it will be mg cos theta. You might have done this part. So if we calculate, so it comes out to be g sine theta minus mu g cos theta, right? Because n is equals to mg cos theta and f is what? Mu into n. So mu mg cos theta and m and m cancels out. So the net acceleration becomes g sine theta minus mu g cos theta, right? This is, let us suppose, A2 acceleration, and A1 was g sine theta when it was smooth, right? The time taken to slide is n times as much to slide on a rough incline than on a smooth incline, right? So we have to calculate the time. So what equation will we use? Both have to travel the distance d. So that means d will be equal to half A1 T1 square, right? So that means T1 will be equal to under root of 2d over g sine theta, right? Let us mark this as first equation, and d will be equal to half A2 T2 square, right? And A2 is g sine theta minus mu g cos theta. That means T2 will be equal to under root of 2d over g sine theta minus mu g cos theta, right? Now it is given that T2 equal to n times the time taken to slide on the smooth surface, right? We will put 1 and 2. This is basically, mark this as equation 2. 1 and 2 in this equation. So we will get under root of 2d over g sine theta minus mu g cos theta. This will be equal to n times under root of 2d over g sine theta. So what we will do, we will square both the sides and we'll cancel out 2d 2d. So from squaring and cancelling, we'll get n square into g sine theta minus mu g cos theta. This will be equal to what? G sine theta, right? And from here we can also see that we have to calculate what? Mu. So mu will be given by, if I take this thing over here and this term over here, so I'll get mu will be equal to n square minus 1 into g, and g will cancel out on all the sides. So n square into n square minus 1 into sine theta divided by of n square cos theta, right? So sine theta upon cos theta, that will be tan theta, and tan 45 is 1, so which will be equal to n square minus 1 divided by n square. So, or I can write it as 1 minus 1 upon n square. So that means option, so this is 1 minus 1 by n square. Now option A is wrong, option C is wrong. Now we are confused between option B and option D. Here it is talking about mu k, here it is talking about mu s. But since sliding was taking place, that means static friction is not acting, that means kinetic friction is acting, that means mu k will be there, which is B.